Hey everyone, in this video we're going to talk about feed-forward control, which is a nifty way of dealing with some of the external forces and factors that could affect your mechanism's motion. So to sort of get a motivation for feed-forward, we need to talk about, just what exactly PID is in sort of a different lens, right? So I mentioned this briefly in 5.1, but PID is what we call a feedback controller. So here's what that means, right? So the system, right, and in the previous video you worked on a shooter, this system needs to do something first before the PID controller can do something. So effectively what's happening is that you have sort of this initial motion, right? And then the PID controller starts acting on that motion, right? So per WPI documentation, which I love the way to describe it, it's called a reactionary measure. So a classic example, right, is that you turn off the stove only after the thing you're cooking starts burning, right? Which is a really unfortunate situation, but that's sort of like in a nutshell what's happening with the PID, right? You only know to turn off that controller because you're responding to the fact that your food is currently burning, right? But we want to do much better than right? We want to do much better than that, right? Imagine if you knew in advance that your food was going to burn, then you'd be faster turning off the stove, right? I mean, if you knew that in 5 minutes, if you don't turn off the oven, your food's gonna burn, then, well, before then, you're definitely gonna turn off the gas, right? So that's really the main sort of intuition behind feed-forward control, right? So the idea is that we want to use information about the intended movement and take part of the actions that you know must be applied to make a system move, and then make that work in tandem with the PID controller to do correction. So it effectively just reduces the amount of overhead that a PID controller has to manage. So in terms of our code, right, from 5.2, we're interested in the velocity gain of the motors. So it's measured in terms of volts, and it represents how the shooter will react to voltage effectively. And this is represented by KS and CTRE terms. So before we get into the code, the main thing that I want to mention is feed forward is kind of like the kick that you give to your system in order to get it moving, right? That's kind of like how I initially viewed it, but the main sort of purpose behind feed forward control is that we want to take what we know about the intended movement of our system, right? And then we want it to work in tandem with PID to do any correction. So because we're reducing the amount of work that the PID controller has to do in the first place, it is a faster way of getting to your desired position, right? So it is very much possible that you could only have a feed forward loop and never use a feedback controller at all. Like that is very much possible depending on the type of mechanism and the constraints that you have. But in this case, we're really focused on combining feed forward and PID to leverage the fact that, hey, we know, or we have this sort of idea of the kind of velocity gain that we want on our robot, right? Or want on our motor, right? We want this sort of gain. And so let's apply this gain and then trust that we know that the gain is sufficient enough to the point where the PID controller doesn't need to do that much work in terms of correction, right? So in the absolute ideal situation, you rely only on PID to do micro corrections in your position or your velocity. I'm talking like a difference of like 20 to 50 RPM is what PID would be responsible for, and feed forward 20 50 RPM within your goal, right? And then feed forward is what gets you to that 20 to 50 RPM difference, right? So that's sort of the idea, right? And so implementation is actually very straightforward. Here I have our code from section 5.2. And you'll notice that we have our configuration here. Let me make this a little bit bigger. There we go. Okay, so you'll notice that we kind of have our sort of PID configuration here that we worked with. These were some default values that we had set before. Now, all we're going to do is add a new parameter called .widthKS, and then we'll set the value to something like 0.1. Again, I will talk about tuning this in a moment and another slide, but that's pretty much all you're going to have to do. Let me get rid of that semicolon, and there we go. So KS in terms of CTRE stands for static feed forward gain. And again, the units will depend on how your mechanism is geared and all of that. So, of course, you're going to have to know a little bit about how your mechanism is structured and how it's designed in order to actually set an accurate feed-forward term. But we tend to start with 0.1 most of our mechanisms. There's something just small in general is a good starting point for your mechanism. So now that's really all you need to do in terms of setting it up. The code for the shooter subsystem itself, if we go here, right, this run shooter velocity doesn't really change because you set a feed-forward parameter. So when you set the new request to be .with velocity, it will automatically account for the fact that you have this feed-forward term. So in terms of code setup, it's not really bad. I would say the hardest part about feed-forward is the actual tuning part. And that's also the unfortunate part about this course and in this section in particular is that, I'm going to jump to the bottom here. Tuning depends and heavily varies on the system that you're trying to tune. And a lot more details about tuning mechanisms can be found on the WPI Lib documentation. Like, we heavily defer you, especially for tuning, to head over to WPI Lib documentation or go to Chief Delphi to read threads about how people have worked to tune different mechanisms, because those are really the greatest first-person perspective resources that you could find on how teams have dealt with tuning all different kinds of mechanisms and all the advice teams have given. So, WPI Lib documentation, the Chief Delphi forum, those are all really good at sort of understanding how teams have dealt with tuning mechanism in the past. So we highly encourage you to check out that documentation and those resources, because it's really great in terms of just understanding how teams have worked with different mechanisms in the past, right? But the general sort of consensus is that you're going to want to make sure first that your PID tuning is accurate. And then you really want to start with a small feed-forward value and then observe the system behavior, right? If the system's consistently overshooting and your PID controller can't do anything for it, then try reducing your feed-forward. And then the inverse applies as well. And then if you still observe overshooting by like a small factor, then you can adjust your PID tuning accordingly, right? So remember, the goal is to make PID do all the micro adjustments, while feed-forward is responsible for really ramping up and getting to your goal, right? So again, the unfortunate part about working in a simulation environment is that we can't actually simulate the mechanism's motions without a decent amount of code overhead and adjustment. And that's not really going to be the priority for this. The goal is to just introduce you to the concept and the idea, right? And so if you really want to practice the implementation of it, you could just take one motor and apply the feed forward and try to get that motor to spinning to like 2000 RPM, right? And then you can see and seeing for yourself how changing the feed forward value impacts how the motor spins and behaves, especially looking at those charts, is really what's going to teach you best in terms of how to tune, right? So if you've got access to your shop, head over, grab a motor, and just write code in terms of using feed forward control, and just see what changing the PID values and changing the feed forward values does. That's going to be the best way for you to learn, even better than reading things like other teams' documentation or the WPI Lib documentation, right? Because at the end of the day, robotics is very much a science, and in science you learn by testing, right? So the more exposure that you get to testing in tandem of watching these videos, the more you'll sort of understand these tuning ideas, right? So that is all for this video. Thank you so much for watching, and we'll look forward to seeing you in 5.4, where we'll introduce a project that you could potentially work on with one of your very own motors, or something that you'd like to work with in the simulation environment. Thanks so much for watching. We'll see you in the next video.